everyone, it's Judy Warner. Welcome back to this week's Ecosystem Podcast. Have you ever heard of Siglent? Because I'm sorry to say that I didn't, was a little embarrassed by that. I started getting to know them a few weeks ago, and I thought, well, I bet you my listeners want to know about them too and what they have to offer. So I invited their application specialist, Jason Chonko, into the podcast to tell us some of his stories from the bench and meeting with engineers like you, and who Siglent is, how they got started, and how they're bringing affordable general purpose instruments to bear on today's market. Before I let you go, make sure you go over and sign up to thedoubleecosystem.com. We've got an online community, a newsletter, and lots of resources for you. So hope you'll come over and join our community. Now let's jump into the conversation with Jason Chonko of Siglent. Hi, Jason. Thanks so much for joining us today. I'm excited to learn about you and this company that I don't know a lot about.
Yeah, it's nice to meet you too, Judy. Thank you for having me on.
Well, I just have to start out, and forgive me for being clueless, but I've been in the industry for like 30 years, and I apologize, but I've never heard of Siglent. So can you tell us about who Siglent is and where they came from? Because I don't see Siglent around a lot.
Sure. No, I completely understand. It's something that we work on all the time. That's part of what I do. So Siglent actually it started in China in 2002. A gentleman named Eric Chin started the company. He was a software grad student working with some friends of his that were hardware grad students in the late 90s and early 2000s, and even on to today. In China, there was quite an entrepreneurial spirit, and so as these folks got out of graduate school or in graduate school, they started to have ideas. I would like to build a company. So our founder started with an idea. His friend was a hardware designer. So they said, hey, we could start a company and we could build test equipment, and we could build test equipment for everybody. We really, in their school, they only had limited access to certain types of equipment. So they started to think, okay, well, if we put this together right, we'll be able to build products that are more affordable and more manageable for the everyday person to get to. So they started on that path. They thought that it was only going to take them 6 months, and ended up taking them about 2.5 years. So they bit off a lot more than they could chew at first. But in that process, they learned a ton about what it takes to build the company and how to build the right type of product. And it's just continued to grow since then. Our office here in North America opened in 2014, and then the office in the EU, I believe, was right around that time as well. And so, yeah, in North America, we've been around since 2014. And located here in Cleveland, Ohio.
Interesting. Well, because I have an RF side of my world, I heard that you guys were getting ready through the grapevine, that you guys are getting ready to launch an RF product. And I'm like, wait, nobody just starts with RF. Where do these people come from? So thanks for clearing it up for me. And I love that story. It reminds me of my ex-employer, where scrappy university, students got together to create something that was accessible to everybody. So that's kind of an endearing origin story. I like that. So what type of, did you say that was an oscilloscope that Siglent started with?
Yeah, started out with a 200 megahertz oscilloscope, and then that product became very popular internal to China and caught on with an OEM. So a bigger company came to Siglent and said, we would like to buy that product and private label it. And that really started the company's successful growth, because now, instead of selling to just the domestic market, they were selling internationally. So the regulations and the compliance testing and all of those other things that have to be done prior to building a really professional grade product, they started to build those types of systems. And then it's just continued to grow. Originally, a lot of oscilloscopes, really one of the world's largest sellers of oscilloscopes, even today. And then our largest volume. And then it started to, people started to ask, well, why don't you make power supplies? Why don't you make arbitrary waveform generators? Why don't you start to make RF equipment? And it's just continued to expand along the same lines, right? We still have that same mentality. We want to provide the right tools to everybody. We want to give engineers the tools that allow them to do their job most effectively. And we don't want to break the bank doing it.
I love that. It's a great origin story, and I'm sure something our listeners will be interested in. So, Jason, how long have you been with, I know you're an applications engineer. So what exactly do you do for Siglent?
Sure. So I started in 2016 here at Siglent. I've been in the electronics industry since 2000. So more years than I than I thought on occasion. You know what I mean? It just kind of pops up sometimes
Yeah,
like, wow, have I really been doing this that long?
I know.
Um, but yeah, so I've been with Siglent for 6 years now, a little bit over 6 years in July, and it's been an awesome 6 years. A lot of growth and a lot of really exciting things. When I first came, we had pretty low end oscilloscopes, and not that that's a bad thing, but it's more exciting from an engineering standpoint. It's always exciting to have new things to work with and work on. And so I've been exposed to lots of new product lines, especially in the RF field. I just traditionally didn't have a lot of RF, but my day-to-day responsibilities are pre and post sales support. And so if customers have specific needs or applications, I can point them in the right direction, do a little bit of coding here and there, and then a lot of feedback to the factory. This is one of the most responsive companies that I've ever worked for.
Hmm.
From the standpoint, we take a lot of customer feedback and feed that back to the engineering department so that we can make improvements. And we've actually done quite a few things maybe a year or two after introducing a product. There'll be some really good ideas that have come out of customer interactions, and we've integrated those into those new firmware revs. Not necessarily a new product, but a new
Right.
feature for an existing product, and that's generally rolled out to the public for free. We've had a few projects like that where it seems like a really good idea, and so we put it into the product and give it away to everybody who already has that product. So, and we continue to operate that way, even on more advanced equipment.
Well, I love that message, and it's why I reached out to you guys as I became aware of you to become a sponsor, because that's the thing that we want to do is empower engineers. So thank you to
Exactly.
your managers for
Yeah.
joining me in wanting to enable engineers. Um, so I'm sure with the kind of work you do, you end up being inside. Like you said, it's engineering driven. So you end up working with engineers eyeball to eyeball, right, and learning what their problems are, how you can address those. So can you tell us sort of how you're seeing what the dynamics are that are going on in that lab and how people are giving you feedback, because you do seem to be more of a general purpose solution. And
Mhm.
so tell us a little bit about that.
Yeah, I mean, we've approached the market in a way that we try to be open, general purpose test and measurement, right? And that's a very broad term on purpose. But things like oscilloscopes, for example, can be used in lots of different ways. So trying to tailor the specific performance of an oscilloscope to as broad an audience as possible.
Mm,
Uh, I've gone to a number of places where I've had, they'll have one specialized piece of equipment. It can do lots of other things, but they bought it for a specific reason that tends to push the price pretty high. One customer in particular was doing military radar, and they had a $150,000 vector network analyzer, and it was locked in a cage, and one person had the keys, and that was the only person that was allowed to use it because it was a complex piece of equipment. It was really expensive. If it broke, everybody's out of luck, right? And so, in order to make sure that never happened, they kept it under lock and key, rightfully so. But that also limited all of the other engineers that had to do work because they all had to schedule off around that same piece of equipment.
mm,
And there really wasn't a cost effective alternative. And in this particular case, I was going in there specifically to talk to this customer about general purpose spectrum analyzers and how they could be used by the general population of engineers at the company
mm.
to do that daily work, right? To have that daily driver and not have to wait for the person that has the keys to give you the permission to use it, or to just schedule it with that particular person. So just having the ability to have an instrument on everybody's desk has
Mm.
really it comes up again and again and again, and it's the place where we're really really successful or helpful.
Hmm. That's a really unique approach. I play mostly in the high end of the market, and it is. This equipment's really expensive, it's really powerful, and for highly specific applications, you really need it.
Hmm.
But then on that day to day, so you're providing that day to day. And what do you think that split is market wise, say in U.S., Canada, Europe ish, in the West, what
Sure.
that split is in general purpose applications versus really high end, pushing the technology limits where you really need that expensive instrument and software.
Well, it's funny. The 80/20 seems to come up a lot, right? It's
Yeah.
just one of those things,
The
and for
Pareto
whatever reason,
distribution. Yeah.
yeah, exactly. And it's like the logarithm or the
Yeah.
yeah, natural log, right? It's just in nature. Poof, here it is, right?
Yeah.
So in a lot of cases, yeah, it's around 80%, or yeah, the 80/20 rule, right? 20% is the specialized, really,
Mm,
really need to have extremely high level performance or a specific feature for that measurement. Um, it's very similar, and we actually have a design philosophy, or one of the ways I like to describe how Siglent approaches their design philosophy. And really, they'll take a look at a market application and they'll say, okay, well, maybe we don't have the technical chops or the capabilities to achieve the highest performance level possible, right? We're not on the bleeding edge of a specific measurement. Part of
right.
that is because we're a growing company and we're learning, but also part of that is where are we, and who's going to listen to us if we have that message, right? So we've got that 80/20. We take a look at that 100% and we say, okay, well, we can't do all of that. That's okay. But wow, it looks like at 80% of the market really only needs this subset of those
Hmm.
or those features. And
Right.
so by taking a look at how to optimize that 80%, really hit the main reasons people are buying these products, and then do that as effectively as you possibly can. And that's really driven our initial product launches, and then we use customer feedback to then polish it and provide more application specific features if they're needed in that particular measurement requirement.
I really like that idea that you're taking that real time feedback. It's especially when a company grows, it's so easy to like, oh, we have this great idea that may
Yeah,
or may not apply if you don't do market research and you're doing face to face market research. So I kind of like that. I like the idea. So what you're saying is kind of this is the every man's or every bench's solution for just that day to day stuff that
exactly.
doesn't
And
apply, and they don't have to go get it out of a cage, or you know maybe they can get more instrument for their buck, right? And not have to tap in until fight over resources.
well, we've had customers that have come to us. They've had a budget for X amount of dollars, right? And they were thinking, okay, we can get one or two benches built for this, and we've actually come in and helped them build 10 benches for that. Again,
Whoa.
depending on what they're looking for, we
Yeah.
may be able to really approach specific needs with pretty budget conscious, budget friendly product. But it isn't cutting corners on the budget. It's or on the performance. It's just tailoring the performance to that specific application and doing it in a cost effective way. Um, I had a customer not that long ago. They were renting $100,000 worth of equipment a month, and they were
Whoa.
trying feverishly. It's a production environment, really critical. A few of the specs that they needed were really critical, and what they found from competitors, it was performance was fantastic, but they could only rent it. It just they didn't have the budget set
I
aside
see.
for the year to be able to do that. So they sat on the rentals for a few months, and they're like, "Wow, we're just burning through way too much cash. We got to figure something else out." And they gave us a call. We sent a demo to them, and within a few weeks, we were already proven. They ended up buying more equipment, and it's just continued to be one of those, like, every quarter they do more. And now, for I think about 25% of their monthly rental budget, they own the equipment, right? So they don't have to deal with the rental. They don't have to, it's theirs. They
Hmm.
own it. They can do whatever they need to do with it. So
Interesting. Well, I don't mean to be teeing up a commercial here, but it's kind of for me. But I think it's an interesting sort of story of a company and the pain point, the pain points that the engineers are having. Did you really say $100,000 a month on
yes,
rentals?
I know that when the phone rang, I did the same thing. I
Whoa.
like, why are you doing that?
Yeah.
It's really, really expensive. But again, their particular application, they needed to have that kind of performance. And on their first look through the market, right? They went to the players that they were used to dealing with, and they didn't dig deep enough. And we need, our job is to make sure that we say, from the mountaintops what we're capable of doing, and prove it.
Yeah. Interesting. So it seems like to me too, because I know I'm thinking particularly when this one RF engineer that I used to know, she had to rent because she was doing freelance work on the side, very capable RF engineer, but she had to rent several pieces of equipment to do the measurements that she needed. So, like, as far as your marketplace goes, is it more like large OEMs, or does those small engineering firms? It seems like that's a a good way, if your price point is that different, that opens up the ability for people like my friend to maybe own their own equipment, which seems like a
Yeah,
better deal to
we've
me.
helped a lot of consultants, single person
Huh.
engineering organizations. That was primarily what we've been doing over the last few years, and over the last year or so, maybe more like two, we started to pick up a larger customers. But with larger customers, you typically have to go through the vendor qualification process, and that could take some time. And
Yeah.
so, in a lot of cases, we're meeting those people now, or in the past year, we've met them, and we're starting to get that paperwork and all of those meetings done so that everybody's comfortable. And I get it, right? You have to vet this isn't, uh, an engineer has to use a piece of equipment to tell them what's happening. You can't just look at a circuit with your eyes and go, oh, I see what the problem is. Well, I guess if there's the magic smoke has been let out, you might get an indication. But
Yeah.
generally speaking, right, circuit design is you have to do a lot of modeling, and then at the end you end up testing it, right? And in
Yeah.
order to test it, you need a scope to see what's happening, or a VMM or a VNA, depending again on what type of tests that you have. But really, the tools are the eyes and ears of the engineer.
Yeah. Nobody wants to see the blue smoke.
No, that's
We don't want
bad.
that to be our our
That is
measurement
bad.
solution. Okay. So, okay, we talked a little bit about RF, but I'm kind of curious about that. I went down the RF path and really got
Yeah,
fascinated with
yeah.
that side of the sort of black magic side of the industry, and really enjoyed it. And that could be tricky. So it sounds like you're coming out, from what I've heard, you're coming out with an RF product. Like, why'd you, since you are more general purpose, what made Siglent decide, or what feedback did you get from your customer that made you want to do something in the RF space?
Yeah, so in 2000 and I think it was 15, we came out with our first RF product, which was a vector, or I'm sorry, a spectrum analyzer, swept super heterodyne spectrum analyzer, 2.1 gigahertz, pretty basic box, but really very, very solid box, good measurement capabilities, nice frequency range, and that type of thing. It was really popular, or still is actually, with amateur radio people. And a
Mm,
lot of amateur radio people would they were professional engineers in their day job.
I
So
see.
they would take it into the office and they would say, look what I got. This thing's really great. And then they would start
Oh,
comparing measurements, but from one box to another. And they'd say, wow, this box, which is really relatively inexpensive, is doing just as well as this $10,000 or $20,000 spec an, again, for specific applications. And so they started to bring it more and more. And then they would come back to us and they go, wow, this is great. You go to 2.1 gig. What about 5 gig? What about 7 gig? What about 8 gig? And it's
mm,
just been that feedback and those types of requests from our customers, really, that have sort of led us into this higher frequency, higher capability. We still have that general purpose, every bench needs a box type of mentality. It's just, again, we're being pulled in different directions based on the customer need.
I
And
see.
so everybody's got a budget and everybody's budget constrained, right? Even if you've got a gigantic budget, it still has a stop point. And so we're there to help you get as much as you can in your on your bench.
And resource constrained and time constrained and
Yeah,
all of that. So it sounds like a good way to sort of meet some of those pain points. So tell us about the one give us a sneak peek. I think this will be coming out a day or two after your release, if I understand it correctly. So tell us about that specific instrument, and again, what engineering problem you're trying to solve there.
sure. So in late September, we're launching two new products that basically, let me think, they triple our current frequency,
Mhm.
our frequency limit. So today our max limit is 8.5 gigahertz. It's very soon going to be 26.5 gigahertz.
Hmm.
So the 26.5 gigahertz gets us into the K band, as well as everything in between from 8.5 up to 26.5 gig. So specifically in that frequency range, you're looking at radar applications, satellite communications, a lot of general or immunity as well for electromagnetic compliance testing and immunity.
Interesting.
And so there are a lot of general applications that just continue to do so at higher and higher frequencies. And so, yeah, general purpose at those frequencies is, it's the same thing. It's just a higher frequency band.
Yeah. I have a friend, Ken Wyatt, who's sort of an EMI expert
Yep, I know
that taught
Ken.
me, about Ken. Yeah.
Yeah, I like Ken a lot. He's a good guy.
Does he have your instrument?
He was the so I knew nothing about RF in 2012. We hired Ken to come in for 3 days. I worked at a
Oh,
different company, but we hired Ken and he came in for 3 days. So he's the first person to teach me anything about RF. So yeah,
he
got
taught me
lucky.
a
I'm
lot
I'm
about,
lucky to have. Yeah, right.
I
He's a
know
very good teacher.
he's been a great teacher for me too, but he taught me about immunity. I wouldn't have known that term,
Yeah.
before I met Ken Wyatt. So I'm like, ooh, this is right in Ken Wyatt's
Oh, it
area of
is. Yeah.
expertise. By the way, for our listeners, I'm going to have Jason send me links to some of this stuff, and maybe we'll put Ken's channel in here. He's very involved in EMI and
Yeah.
has some great stuff there. So we'll throw that in. Um, so you're going into a higher frequency range. I mean, those applications. So are you really, does that include military radar and satellites, or is it more automotive, consumer? Like, where does that land? Because I honestly don't know.
Yeah, well, there are a few different technologies. It does depend. I think it's civilian and military in that K band. There are some satellite up and down communication links, and then there's stuff all the way up to past 100 gig. Obviously, we're not quite there yet,
Yeah.
but yeah, we're basically staying in that 26 gig. But the company's always evolving. I wouldn't be shocked if higher frequencies were right around the corner in any of our product lines.
Hmm.
Um,
So in that, you said there was two products.
mhm.
So that is the I'm sorry, VNA or spectrum analyzer.
There's a 20 gig RF signal source coming, and then a
Okay.
26 and a half gig spectrum analyzer.
Uh
So
huh.
the RF signal source is obviously responsible for providing the signal that you can test receivers and you can test components with. The spectrum analyzer side is measuring a transmitter or something that's capable of outputting a specific frequency range, and so they play together within
I
that
see.
within that space. So typically,
Okay.
if you're building something in that environment, you would have both a signal source and a spectrum analyzer so that you can measure both sides of it, because you're usually building transmitters and receivers in the same, generally a different team, but they're usually in the same
Yeah.
place.
Yeah.
Yeah, at least
Um,
technically.
well, that's kind of good that they play together, right? Because I've heard
Yeah.
some stories about the signal generator and the instruments not playing well together. Um, so did we talk? What's the bandwidth? You said it's under the K band. Sorry if I'm asking dumb
Oh,
questions,
no, no, no
because I
problem.
am learning in real time in the last 6 months about the test and measurement world. So forgive me if
Sure.
I'm asking obvious
No,
questions, but
not a problem.
I'm learning from you, and I hope our listeners are too. But
Yeah, so
you,
you generally have a starting frequency, and that's usually not zero. It's really difficult to manufacture both low. One design is really difficult to make low frequency and 0 hertz or 1 or 10 hertz. Very difficult to go from there to really high gigahertz. Not impossible, but really difficult, and also really expensive. And so, in general, the trend is to go from 9 kilohertz. I'm not a design engineer, so I don't entirely understand why it's always 9 kilohertz.
huh?
But in a lot of ways, if you look across the board, different vendors and products, they almost all spectrum analyzers start at 9 kilohertz, or a lot
Hmm.
of them do. And then function generator, or I'm sorry, RF signal sources also tend to start at around 9 kilohertz. Now, um, the 20 gig or RF signal source is going to be, I believe it's 9 kilohertz. The spectrum analyzer is going to start at 100 kilohertz and then run all the way up to 26 and a half gigs. So what that means to the user, that wide range, you can use it anywhere you need to. Right?
I see.
Today you might be working at 2 gigahertz. Tomorrow you might be working at 20. Well, now you
I
don't need to
see.
have two boxes. You could just have one that covers that whole span.
Got it.
And again, so you're getting more coverage out of one piece of equipment than having to go get another piece of equipment to do that same
That
job.
totally makes sense. So, Jason, I really get why this is resonating, on the general purpose side, even on the RF, that you have these range of things you can do rather than, a very narrow application specific, bleeding edge. So that makes a lot of sense to me. But you said something a little while ago about the price that kind of blew my mind. Like when you said affordable, but then you said, oh, one high end instrument to 10 of something from Siglent. I'm like, wait, it can't be that much less expensive. So I'm not asking you to tell me what your instrument prices are here, but like, how do you do that? Even if you are in that general purpose range, how do you stay affordable and not be like the Me Too company?
Sure. I think the a lot of our money, a lot of the profits go right back into R&D. If you take a look
Mhm.
at how we develop product and how many products we've released in a year, and all of that is in house. We don't buy, resell, we don't OEM
I see.
products. Our instrumentation is designed by Siglent engineers. It's manufactured by Siglent, so we have control over the entire process.
Mm.
And almost all of it goes right back into R&D. We have a large R&D department. We don't have a large marketing department, so we're spending a lot more money on the R&D side, which is really what engineers are using, right?
Mm.
Marketing is very important. I totally understand it, but at the end of the day, the engineers are using the tools. They aren't using the
Yep.
marketing tools, and
Which
so
is probably why I don't know about you.
yeah, that is true. And my job is to help elevate that a little bit. But yeah, we have we have work to do to get our brand out there for sure. But everybody that touches on our brand, they come back and they're really excited. A lot of our customers are repeat customers, and that's how you grow, right? Building
and
that trust.
and I'm guessing I'm being the devil's advocate here a little bit here, but I'm guessing the quality's good and that
Yes,
it's standing up, to the kind of kicking the tires, right? And so what are you again, I feel like I'm being a devil's advocate here, but you said you weren't cutting corners, but under the hood, because you are able to design and manufacture in house, like, what is the quality?
sure.
I'm kicking the tires for our
Oh no,
listeners,
I
like,
yeah,
so,
no, I totally understand.
okay.
We use a lot of components that you've heard of before, right? So from the bigger manufacturers, I think we're a very large customer to TI, ADI, all of those companies. And one way that you can see that is, there are quite a few reviews. We live in a great age where you can actually, the consumer can directly view what's going on
Hmm.
with professionals testing the products on their own. So if you did a quick search on Siglent review or unboxing, you'd find quite a bit of them. And I'll share a few links with you if you'd like.
Okay, great.
To
That'd be
some,
great.
we actually came out. One of a really difficult instrument to manufacture, to design and build, is a vector network analyzer. And they're just complex based on just the nature of the beast, right? And so we came out with our first vector network analyzer last year. And we didn't start on the low end. Typically, what we do is start with a base model and then kind of grow the frequency range. Last year, we kind of went right for it and built an 8.5 gig VNA. And it's been reviewed recently. Again, I'll share that link with you.
Okay,
And
great.
they open it up. They talk about the circuit design, what's unique about it, and then also the components that are used in it. So we don't cut corners on the design side. Again, we can't build a company if we don't build the trust. Test and measurement engineers have to be able to understand what they're looking at and
Mhm.
trust what they're seeing.
Right.
If the instrument's lying to them, then they can't trust that company because they're using these tools all day, every day to do their job. If the tools don't work, they need to find another tool. And they don't need to stick with Siglent. They don't need to stick with
Right.
whoever. If you fail them, they move right on to somebody
Yeah.
else.
Yeah.
And
They don't have time. They don't
no,
have time.
no, and I get it, right? Everybody's
Yeah.
like that. You only have a
Everybody.
limited amount of time to get your job
Yeah.
done, so you pick what you trust and you go with it because it got you there before. And it's our job to earn it.
Yeah, and it's like their job on the line and their profits, and sometimes, if it's going in a car, it's kind of important that what you're designing is that the models can be correlated to the measurement, right? So
Yeah, well, it's funny. I took shop in high school. I'm that old that they actually still had shop. Um, and in my shop class, my teacher, one of the first things he said was, "If you built, or would you fly in a plane that you built?" And that always
Yeah,
stuck with me. I'm like,
right.
I get it. Yep.
Yeah,
Would
I
you?
know. Yeah, I worked for a military, I covered the West Coast in sales and marketing for a really high-end military, assembly, turnkey assembly place in Baltimore. And one thing I was impressed is like their controls are really tight and all that. And I'm like, this is really impressive. And so he's like, well, there's mothers whose sons are going to sit on top of the stuff we're building. And we're aware of that every single day. And I'm like, I like these guys,
Yeah.
because they I think, and engineers, I think, have a keen sense of what's riding on the products they build. So I really
Well, and
appreciate that.
they want to be proud of what they
Of
built, right?
course, it's like their children.
It's an
Yeah.
extension of them. It
Yeah.
really is, right?
Yeah.
And it's the same. Our engineers, right? They're mainly in China, and they're some of them have just graduated, and they're really proud of what they did. But
Yeah.
the great thing is if they're also open to listening and being able to balance it, right? Because they're not just building it for them; they're building it for other people. It really is. I really enjoy it. I didn't start in this industry thinking
Yeah.
all of these things or knowing all of these things, but that's some of the stuff that I come back to and I really, really enjoy about, working here, working in this industry and the
Yeah.
customers.
Me
It's a lot
too.
of really cool technical stuff and the people are great.
No,
It's
I
a
agree
good
with you.
balance.
There's definitely a passion for engineering, and like you said, that pride. And the other thing that I think is so interesting is like they know they're going to be engineers at like 5, a lot of them, because they're taking stuff apart because they got the knack, and so it's really
I,
interesting. But I
I have a
share
story
your
about that for another time, maybe, but
no. Tell me about the knack.
so I was a little kid, probably 7 or 8 years old, and they had these little tiny toys. They were called stompers, and you would put a AA battery in them. It was a little car, little
Uh
motor.
huh.
You put a AA battery in it, you turn it on, and a light would turn on the front. They had little fiber optic or light guides on
Yeah.
this little tiny lamp, and it would drive across the carpet or whatever.
Right.
And one day I watched my mom plugged the vacuum cleaner into the wall and we had a light on the vacuum cleaner. And I noticed that light was really, really bright and it was plugged into the wall. And I saw my stomper and I knew it had this little battery in it. And I thought, well, if I plug the stomper into the wall, it's going to be even better because this motor is going to get a ton of juice off the wall, right? I mean, in my 7-year-old brain, I'm like, I knew enough to know that the wall outlet had a lot more juice. And I did
See,
it.
that means
I wired it up and plugged it
you
in.
had the knack.
I
By
did.
the way,
I blew the lamp up and almost electrocuted myself, but
that's awesome. I love those stories uh, because it's so true. Have you seen that? I'll share it in the show notes. There with I think it's Dilbert,
Okay,
and she
yeah,
takes her. Anyways, I'll throw that in the show notes just for fun. A little video about, ma'am, your son has the
the
knack.
knack. Uh-oh.
It's like, oh no, the knack.
Everything's gonna get taken apart. Yeah,
Yeah, no, it's
that
so
was my
good.
grandparents would always call and they're like, "Can you help us fix this?" I'm like, "Yeah, I think so.
Yeah.
Sure, why not?" I think that's a lot of it too. Also, engineers they tend to not be afraid of trying to do something.
Mm-hmm.
You once you get a toolkit, you have enough confidence in what you're doing. It makes it a heck of a lot easier. But at the beginning, it's I don't know. I want to
Yeah.
get this thing to work, so I better figure it out. And get out the hammer and start swinging.
Yeah. And it usually ends up in those funny stories like you blowing up the lamp.
Yeah.
And then
Yeah.
when you grow up, it becomes the blue smoke. So great stories. And you're right. It's a lovely group of people to be around and to learn from. And I thank you so much, Jason, for coming on and telling us about, who Siglent is in the first place, but also telling us about how you were founded, what you're up to. And I'm really glad to just be learning about you, and I thank Siglent for joining us as a sponsor, but we really haven't gotten acquainted yet. So this has been really exciting, and I'm sure our listeners will enjoy it as well. Any final thoughts before I let you go?
Just thanks again for having me on. I appreciate it. I hope I didn't ramble too much. Yeah, it was great. Looking forward to more.
Thanks so much, Jason. To our listeners, thanks so much for joining. I hope you enjoyed this conversation as much as I did. We will see you next time. Don't forget to check out the show notes. I'll put in all that good stuff about Siglent and even the Knack. I'll put all kinds of good stuff in there for you to
The
go poke
knack.
around, get some information, and go check out Siglent and see if that's something that meets your needs. So thanks so much for joining us. We'll see you next time. Until then, remember to always stay plugged into the ecosystem.